Yeah, hi guys, welcome to the present video. So in this video, I'm going to discuss about only one question, guys. So it is a very short video, and this question was asked in the previous UGC NET exam, that is 2020 and 2021 mid cycle. So the question is, all of you might be aware about this question, so that's why I kept the question on the thumbnail itself. So before going into the solution of this question, if you guys not yet subscribe the channel, then please do subscribe, and please share these video links in your respective groups. Okay, so let's maximize and let's gather the electronic science candidates. Okay, and in the description box of this video, I kept the WhatsApp group link also, so all of you join in that link. Okay, whenever I'm doing the video, even though if you did not get the notification from the YouTube site, but I will put that link in that WhatsApp group link. Okay, and please join in that WhatsApp group link the candidates who are preparing for the electronic science related competitive examination only. Okay, so otherwise it's just wastage of joining in the group, right? Okay, so coming to the main content of this video. Yeah, so let's have a look at this one. The candidates who given the examination, the last attempt, all of you might be very much aware about this question. So water flowing in x direction has a rate of bx is equal to 3yz liters per minute per meter square. The total flow or flux of water through the rectangular area with the corners given here. So 0, 0, 0 and 0, 3, 0, 0, 0, 2 and 0, 3, 2. Okay. So actually, as per this given, if you look at this given coordinates, we can easily understand that it is a three-dimensional, okay, or as a rectangular coordinate system. So we have to take the three axes. So it is the x-axis, it is the y-axis, and it is the z-axis. Okay, and so the first point they kept at the origin, so we can take here, and the next one is 0, 3, 0 means at the y-axis they mentioned. So let's take the 0, 3, 0 means here one point. Okay, so let's take it is A, B, C and D. So A point I mentioned here and B point I mentioned here at 3, and 0, 0, 2 means so it is a Z axis. So one point I represented here C, and 0, 3, 2 means so it is the y axis 3 here and the Z axis 2 here. So intersecting point of both these two, let's take one point. Okay, so now whatever the rectangle they asked, now I will get as like this. Okay, so it is a rectangle. Got it? So A, B, C and D points. So now they are asking the total flow or flux of the water. Okay, just remember here flux and Bx. Actually Bx or else the B represents what? B represents the magnetic flux density, correct? And x means the magnetic flux density along the x-axis they are asking. Okay, so along the x-axis means basically what is the relation between the flux and the magnetic flux density. Here the flux means we will represent with like this. So in the magnetic field concepts, the flux can be taken as like this. If it is in the electric field concept, flux can be taken as like this. That means in the magnetic field concept, psi is equal to integration of B into ds, where B is the magnetic flux density and where D is the electric flux density. But the question is magnetic related one, so I can take this expression. Flux is equal to integration of B ds. And here let's focus on this ds only here. Okay, ds only. Actually, ds can be taken as a dy dz along the x-axis, or else dx dy along the z-axis, or else what's left? Okay, x and z, dx dz and along the ay. So we can take any one of these representations as a ds. But in the given question, they clearly mentioned that B suffix x means the magnetic flux density is along the x-axis. Okay, that means we need to take this format. Why? Because it is along the x-axis means you have to take the unit vector as a ax. Okay, fine. So now let's take the help of this expression, this one. Okay, so let's focus here. Then I can write that flux is equal to integration of B ds, that is equal to ds, where S represents the surface area. Surface area means what is the units of the surface area? Meter square, means 2 dimensions we need to take. So let's take the 2 dimensions. And what is the B expression given here? B is given as a 3yz. So let's take 3yz here, and in the place of ds I am substituting the ds. I am substituting this one, that is dy, dz and ax. Okay, all of you understood? So later I am taking this one as like this. So please have a look here. Yeah, just a minute. Fine. So that is equal to integration of, let's take the 3 is a constant. So let's take that constant outside. So 3 into y dy integration of z dz ax, that is a unit vector. So I took as like this. That is equal to 3 into integration of y means y square by 2, integration of z means z square by 2. Okay, ax is a unit vector. So let's leave about that one. That is equal to 3 into, if you check at the figure, what is the y given there? What is the y and z? What about the y and z? Let's check down. So y is the 3 and z is the 2, right? So y is the 3 and z is the 2. Then substitute those values here. Y is the 3 and z is the 2. Now by simplification, 3 into 9 divided by 2 into 4 divided by 2. So 2 2 and 2 2 gets cancels. Then finally we will get 3 9s 27. Got it? So 3 9s 27. That means I got the flux. Flux is equal to 27 liters per minute. Got it? So for this one the answer can be taken as a 27 liters per minute. That is option B is the correct answer. All of you got it? Option B is the correct answer. That is 2938, option ID. So it is how we have to solve this one, guys. Okay. So most of the candidates are worried about this question. So how to solve and what is the solution procedure. Okay. So here the thing is that you should know about this expression, and the ds has to be taken as this thing. So if you guys know about these things, then automatically we can solve this type of questions. Okay. So by this question, so let's focus on some ds in the 2-dimensional, ds in the 3-dimensional. Okay, and spherical coordinates. Okay, don't much focus on the spherical coordinates. Okay, just focus on the rectangular coordinates in a wide area. Okay. Okay, so it is a question, that's what I discuss in this video. So few more questions that we will discuss in the coming parts. Okay. So in the description box of this video I kept the WhatsApp link. So please all of you join in that link so that all the updates will be, I'm going to update in that link itself. Fine. So thank you very much, guys.